Okay,
Yes, ma'am.
so we'll start. Mm-mm. So this is inspection of poultry and aquatic foods, mainly fish for the human consumption. So we'll do first for the poultry eggs. Okay. And this inspection of the poultry eggs is broadly classified into two types. That is the physical quality of egg and the bacteriological quality of the egg. Just 1 minute. One of your friend has entered just now. One is physical quality of egg, and the other one is bacteriological quality of the egg. So, under the physical quality of egg, it is again subdivided into three types. That is the physical characteristics of egg, then the physical composition of egg, and grading of the chicken egg. And the other one is, as I have said, bacteriological quality of egg. So this physical quality of egg, the first one, the physical characteristics of egg is again subdivided into five different categories. That is the egg weight, the shape, the shell color, the specific gravity, and the texture of the egg. So let's see the first one, that is egg weight. So this egg weight, the weight of the egg is influenced by the species, breed, plan of nutrition. Just excuse me. I'll just admit one of your friends. So this is influenced by species, breed, plan of nutrition, environmental temperature, body weight, and disease. So in general, the egg weight of a chicken is 56 gram, duck is 68, turkey is 65, and Japanese quail, I think you must have seen in our LPM farm also, we have Japanese quail that is 10 gram, but this ostrich egg, usually it is 1.5 kg. So depending upon the species and the breed, the egg weight is different. Okay. So the second one is the shape of the egg. So normal shape of egg is oval, but this oval in shape is varies from spherical to elongated type or cylindrical, elliptical, conical, or biconcave in shape. So the shape index for the normal egg varies from 70 to 74. So you can calculate the shape index by dividing the width with that of the length and multiplied by 100, and you will get this shape index. Okay, so try to know all these small points. It used to come in your objective for competitive exam as well as for JRF and all these things. Okay, the shape index of the normal egg is 70 to 74. Then the share color. Okay, so this is of interest in context to the consumer preferences. So it is genetically inherited character due to the pigment porphyrin. So as you have seen, chicken, it is chalky white to brown and dark creamy white, turkey tinted, Japanese square blotch, and this color of the egg, it really affects the consumer's preference because here also in Mizoram state also the brown egg is expected to be more nutritious, but it is not. Okay, it is just the covering of the shell. So whatever egg, whichever is fresh, okay, whichever is younger, that is more nutritious. It does not depend upon the shell color. Okay, but it has a great influence from our uh, forefathers. Okay, then the specific gravity, you mark these things. Normal specific gravity is 1.09. Normal egg, their specific gravity is 1.09. So this specific gravity, it varies from the fresh laid egg to the stored egg and the aged egg. So this specific gravity can be calculated by dividing the weight with that of the volume. Okay, so um, the fifth one is the texture, which comes under the physical characteristics of egg. So it indicates the external abnormalities such as ridges, grooves, calcareous deposits, depression, glossy or dull appearance. So the above said physical characteristics, all these ridges, grooves, calcareous deposits, this will affect the consumer's acceptance and also considered in their marketability. So we have to be very cautious for this. Then the number B, the physical composition of the egg. The first one is the physical characteristics of the egg, which comes under physical quality of egg. Now we'll go to the physical composition of the egg. So this physical composition of the egg is divided into three parts. That is the shell, yolk, and the albumin. So the shell, including the shell membrane, comprise of 11% of the chicken egg, and the yolk comprise of 30%, and the albumin comprise of 59%. This percentage is normally for a normal egg. Okay, so mark all these things. Shell, including shell membrane, is 11%, yolk is 30%, and 59% is the albumin. So eggs are number C, that is grading of the chicken egg. So egg, they are graded and marketed based on the weight and the quality. So let's see, according to BIS standards based on the weight, extra large egg is 60 gram and above. So this is for chicken egg. Okay. So large egg is 53 to 59 gram, medium 45 to 52 gram, and small egg is 38 to 44 gram. So when the hen lay egg in the first time, it will be small. It will be around 38 to 44%, 44 gram. And then when they become older, the egg size also will be bigger and the weight also will be more. So this is the egg quality. So there are two types of quality, grade A and grade B. All this blue color is grade A and the B color is grade B. So according to BIS standard, based on quality, there are grade A and grade B. And within grade A and grade B itself, the weight, the mm, weight grade, then the size, the shell, air cell, white, that is albumin part, and the yolk is different. So this grade A can be extra large, large, medium, and small, and this is same in the case for grade B. But in the case of grade A, which we considered chicken egg grade A, the shell will be clear, unbroken, and sound, and the shape is normal. And the air cell is also up to 4 millimeter in depth, and practically it is normal. And the white part, the albumin part, is clearly reasonably firm. And the yolk, it is fairly well centered, practically free from defects, outlined, indistinct. So when you boil egg, okay, when you boil egg, if the egg is very fresh, okay, it will be at the center, the yolk, okay, it will be at the center. And after boiling, if the yolk is at the side or attaching to the shell membrane, that indicated that the egg that which you have boiled is of old one or lower grade quality. Okay, so for the shell of grade B, it is clear to moderately stained and sound, and the shape is slightly abnormal. And the air cell also can be up to 88 mm in depth, and it may be free or slightly bubbly. And the white part, the albumin part, will be clear. It may be slightly weak. So when the egg is very fresh, okay, it will be very firm. But when it becomes older and older, the white part, no, it become loosened and weak. Okay, then the yolk part, it may be slightly off-centered and outlined slightly visible. So egg quality can be measured by various methods: external appearance, candle out appearance, internal qualities, physical chemical qualities, and the domestic methods. So the external appearance can be observed for crack in the shell, broken shell, clean shell, dirty shell, abnormal shell. Okay, so all this indicated that the grading of the egg will be lowering down. Then the second one is by candling out, we can see the depth of the air cell, free air cell, bubbly air cell, okay, and blood spots and meat spots, it can be detected with the help of candling. Then internal qualities, it can be assessed by the quality of the shell, the albumin, and the yolk. So other factors which are used to assess the quality is to observe for the presence of foreign materials in the albumin and the yolk, like the blood spots, meat spots, tissue debris, parasites, etc. And the internal quality, we can check the shell quality. Okay, the shell thickness. See, a good quality shell will have shell thickness of 0.35 millimeter and the cell porosity. Okay, greater the number of the pores, weaker the shell. Then the shell percentage is measured by the shell weight divided by egg weight into 100. Then shell breaking strength, this also indicated for the quality of the egg. So it is measured by measuring the crushing strength or piercing strength. Then the shell specific gravity. Then the albumin quality can be calculated by using albumin index. That is, like for fresh eggs, albumin index is zero point 0.1. So when the egg become aged, the albumin index become lower. So there is a unit called a haunch unit. So this is a method the albumin height is adjusted to the egg weight and the haunch unit is calculated using the formula. So this is the formula for the Houch unit. Houch unit is equal to 100 log H plus 7.57 minus 1.7 with 0.37. So H indicated the height of the thick of the albumin with that slide calipers. No, you can measure. No, I think you might have done this one in LPT practical also. Then the weight is W is the egg weight. So Houch unit value of 80 and above indicate the freshness of the egg. So when the air quality deteriorates, the house unit value also will be decreases. So percent of thick and thin albumin, you mark these things. Okay, a fresh egg they will have means a freshly laid egg. Okay, on the day of laying, see a fresh egg it will have 55% of thick albumin and 45% of thin albumin. So when the egg is aging, the thick albumin it will become watery, and then the percentage of this thick albumin will be reduced. Then it will be reversed when the egg become aged. So it might be 55% for the thin albumin and 45% for the thick albumin in the aged egg. So with that also you can differentiate whether the egg is uh, fresh or old egg. And also you can see the presence of foreign materials. Then the yolk quality, this is assessed by the yolk index. So a good egg has a yolk index of zero point 0.4. So lesser value indicates deterioration of the egg quality. And egg color. Okay, this is slightly impress all the consumer, isn't it? We want a good yellow yolk, isn't it? But it is not a quality factor. We have to remember this. Since from our childhood we were told like that that the egg, when we crush the egg for frying and all, if we found that the egg is having a very light yolk, then we thought that it might not be nutritious, but it is not so. So it is related with the color pigment present in the feed. Suppose if the hen is eating large amount of this maize and other thing, then or suppose if that hen is taking green leafy vegetables, the yolk will be automatically more yellow in color. Okay, so the instruments which is used for measuring the yolk color is Roche yolk color fan or Fletcher's scale or Van Wagenow chart. Then the foreign material, like there is a term called yolk mottling. Yolk mottling means the normal yolk, as I have said, it should be yellow in color. It might be light yellow or it might be dark yellow, but normal yolk, it is yellow in color. So if there is any discoloration noticed in the yolk, then the discolor spot is called mottling. Mottling. Okay. So which may be due to drugs like nicarbazine, monensin, or maybe due to deficiency of vitamin A. Okay, so we should not confuse with rotting. So it will come in the bacteriological quality of the egg part. So when there is any discoloration noticed in the yolk due to discolor spots, which may be due to some drugs or maybe due to deficiency of vitamin A, we call that one as mottling. And this is important, yolk centering also. See, as I have said, in the fresh egg, the yolk is well centered because you know why? Why fresh egg yolk is at the center? Because the albumin, the thick albumin is at that time 55% and it is firm. So it does not let the yolk move to here and there, isn't it? Within the shell of the egg. So it will be at the center, yolk centering. So in the fresh egg, the yolk is well centered, but when the egg become aged, as I have said, the albumin become loosened, it will become watery, then the thin albumin will be more, and at that time it will let the yolk move here and there. Okay, so and if the egg is too old, then it will let the yolk attach to the shell membrane. It might be adhering to the shell membrane. So that term is called stuck yolk. You got my point. Yolk centering is the yolk is at the center. But when the yolk is adhering to the shell membrane, it is called stuck yolk. Now, the fourth one, that is the physical chemical methods under grading of the chicken egg. The pH of the albumin and the yolk is estimated. So this is important. Okay, try to remember the fresh egg. In the fresh egg, the albumin is alkaline, that is pH 8, and the yolk is 6. pH of yolk is 6 and albumin is 8. So the whole egg, combination of the albumin and the yolk as a whole, it is 6.8. So easy to remember. Okay, yolk is 6 and albumin is 8. So fresh egg pH as a whole is 6.8. So as the egg ages, the carbon dioxide escapes from the egg, leading to increase in the pH. So why there is increased pH in the yolk? Because of the escape of carbon dioxide from the egg, as well as pH also can be increased due to bacteriological contamination in the egg. So the fresh egg as a whole, the whole egg is having 6.8 pH, and the albumin alone is alkaline, that is 8, and the yolk alone is 6. Okay. Then the second category, the first category is finished, that is physical quality of the egg. Now let's see the bacteriological quality of the egg. So we know that the fresh egg is 6.8, which creates a favorable environment for growth of most of the microorganism. That's why egg also it spoils faster, isn't it? And there is also pores in the egg also, no? That's why. So the most common form of bacterial spoilage in egg is called rotting, Rottting. So please don't get confused with mottling. Mottling means just the discoloration of the egg, mostly the yolk of the egg, and that is due to drugs like nicarbazine, monensin, and due to deficiency of vitamin A. So that is called mottling. But when there is bacterial spoilage of egg, it is called rotting. So there are different type of rots due to bacterial contaminations in the egg: green rot, black rot, colorless rot, pink rot, red rot, mustard colored rot, then pink spots. These are all due to all these organisms, bacterial contamination. Okay. Then a serious effect is the inclusion of Salmonella enteritidis in the egg content. So in the previous classes and all also, I have told you poultry and poultry products. For this, Salmonella is more prone to them. Okay, so organism is able to invade the ovary and oviduct to colonize there as well as in the other body tissue. So the entry of microorganism into the whole egg is favored by high humidity. Under such condition, growth of microorganism on the surface of egg is favored, followed by penetration through shell and the inner membrane. So that is all about your uh, inspection of the inspection of fish. Let's just revise once. I think you can see like this also. Physical quality. Inspection of poultry egg is broadly classified into physical quality of egg and bacteriological quality of egg. And again, it is subdivided into three parts for the physical quality, that is the physical characteristics of egg and the physical composition of egg and the grading of the chicken egg. Then this physical characteristics of egg is again having five sub number, that is egg weight, shape, shell color, specific gravity, and the texture. So this is the physical characteristics of the egg. Then coming to the mm, coming to the second one, that is the physical composition of the egg, we are getting three parts, as I have said, right? We have shell, yolk, and the albumin, physical composition of the egg. And after this, we have grading of the chicken egg. So it is based on the weight and the quality, and all these are the weight and the quality basis. So we can grade the chicken egg externally and internally, isn't it? Externally by all the external appearance, and internally we can check the shell membrane, we can check the albumin, we can check the yolk, isn't it? So that is all about the mm, inspection of the chicken egg. Okay, so the second one is the bacteriological quality of the egg. So here we are getting different type of rots which is caused by bacteria, and we call that one as bacterial spoilage of the egg, and the name is termed as rotting. Right. pH of fresh egg as a whole is 6.8, and the albumin itself alone is 8, and the yolk is 6. So from there also you can batch up 6.8. Okay, the pH of the fresh egg. So now let's go to inspection of fish. Or do you have any questions from here up to egg part? Any question? Okay, then I will proceed to the next one. This is inspection of the fish. So this inspection of fish for the physical and the bacteriological quality, salt water and the freshwater fishes, they contain comparatively high level of protein and other nitrogenous products. So carbohydrate in fish is scarce and the fat content varies. So internal flesh of the healthy live fish is sterile, and bacteria that is present in the fresh fish is found in three regions. Okay, mainly outer slime, the gills, and the alimentary tract. In these three main position, you will get more bacteria: outer slime, gills, and the alimentary tract. And among the three in gills, you get more. Okay, among the three also you'll get more. So fish is likely to get spoiled by bacteria, and salted or dried fish is likely to undergo fungal spoilage. And the most susceptible spoilage part is the gill region. Then early sign of bacterial spoilage may be noted for off odor. If you get some pungent smell, that is the early sign for the bacterial spoilage. So fish inspection can be done by three methods, that is the visual examination, physical examination, and examination with smell. So there are two categorization of fish, that is the fresh fish and the stale fish. This is important, okay? The odor, from the odor, fresh fish is fresh and pleasant. Stale fish varies from slightly unpleasant smell to non-shading putrefied smell. So in general, a distinctive sour or offensive odor of decomposition is present. And the eye of the fresh fish is full bright, perfectly fresh. Pupil is jet black and convex cornea, which the cornea is yellowish in color. And the sailfish, they are shrunken, covered slightly with slime, which is often transparent. Pupil also, it will be sink and lose the blackness of staleness advances. And milky white pupil is a sign of staleness indicating immediate condemnation. Then the third one is the flesh. So how does it look? The flesh is fine, elastic to touch, white to bluish or translucent, and it attaches to the bone and difficult to tear in the case of fresh fish, and the blood is bright red in color. In the case of stalefish, flesh is soft, flabby, pit on pressure, and reddening is seen along the backbone, and the flesh is torn off easily from the bone, and the blood is chocolate brown in color. So you have to remember these differences so that you'll be able to differentiate uh, the fish, whether it is fresh or not, before you buy the fish. Okay, so the muscle, the flesh is easily torn off or easily taken off from the bone, and blood is chocolate brown in color, and it has a flabby or pits on pressure. Okay, then the gills of the fresh fish is bright color, clean and free from slime. And the case of shellfish, it is dark brown in color and sometimes discolored, and slime is also present. Then the appearance. It is appearance as a whole for the fresh fish: clean, dry, smooth, glistening with firm scales, moist with transparent slime, and show no discoloration. But in the case of shellfish, fish look lifeless, dry, rough to touch with a gritty feeling. Scales are easily rubbed off. Some degree of brown, red, or bluish discoloration of abnormal wall are present. Okay. Assessment of the fish quality, you can have a sensory assessment as a means of determining the quality. So there are three variables, that is the sample under investigation, the assessment method, and the judges. So there are two distinct type of sensory methods: subjective and objective sensory methods. So in the case of subjective assessment, it is they are available in determining consumers' preferences and acceptability. And under this, there is a hedonic scale using qualifying objectives such as like, dislike, good, bad, etc. And in the objective one, the fresh waste is most commonly determined by the objective scoring using a predetermined scoring scheme based on the sequence of organoleptic changes that occur as the fish ages. So the principal criticism of objective scoring is that they require extensively trained expert judges, but an advance is that the panel can be quite small. So there is the most comprehensive scoring scheme for assessing fish, that is the Tory scheme, which has been widely used in original and modified form. So in order to be an expert for this objective scoring, they should be the judges. Okay, they should be very expert in order to differentiate the thing. So this Tory scheme is having seven scales: four for the raw fish and three for the cooked fish. So they will see the texture, the odor, the flavor, everything. Okay. And if they score 5 to 10 for, they will give very fresh uh, for the fish, and 0 to 0 for the putrid one, and below 5 is normal. Okay. Then gradings for this is done in Europe and all. So under grade E, that is extra greater than 2.7, then 2 to 2.7 is grade A, between 1 to 2 is grade B, and below this is unofficially, and they have marked them grade C. Okay. So necessary method for determining the quality, there are three commonly quoted chemical assessment for the determination of the quality of the fish. That is total volatile basic nitrogen, trimethylamide, and hypoxanthine. Okay, so these three methods also can be applied. So if you want to see in more detail, you can browse internet for all these methods. We'll not go into deeper. You just if you know the name also, this is enough. Now we'll go for the microbiological quality methods for assessing the quality of the fresh fish. So I think you know in the previous classes and all, we have said that the pH of meat is 7 to 7.2. Okay. And even for egg is 6.8, isn't it? Fresh egg. But again, fish, the pH is still lower. That is 6.2 to 6.5. Okay. So because of this, it has a shortest storage life, the fish, in compared to egg, in compared to meat and chicken and all. Okay. For the case of meat, the pH is 7 to 7.2, and it is on the alkaline side, isn't it? But for the fish, it is 6.2 to 6.5. Even egg is 6.8, so it does not reach that pH for the egg also. So fish, they spoil very fast. So if I ask you why fish spoil faster than other meat, main reason is due to the pH of the fish, which is 6.2 to 6.5. Okay. So it may be due to some other bacterial spoilage and all these things also, but the main one is due to the pH of the fish. Okay, so these are some uh, Shigella, Pseudomonas, Moraxilla, Acinetobacter. These are some of the bacteria which we used to get in the case of um, fish. Okay, fish bacterial spoilage. And apart from that, this Vibrio cholerae is also one of the important bacteria which we have to uh, keep in mind. Okay, for the fish. So direct plating on this TCBS, this is thioglycolate citrate by salt sucrose agar. Uh, It may be used for heavily contaminated food. So food samples usually they require two stages isolation procedure, enrichment and selective plating. So whenever you isolate organisms from food samples or any samples, then you have to go for enrichment media as well as for the selective plating, isn't it? Enrichment means it will help in the multiplication, faster multiplication of the wanted bacteria, and after that, in selective plating, it will selectively grow the wanted bacteria. Okay, so enrichment by using weakly selective media as alkaline peptone water of pH 8.6 supplemented with 3% sodium chloride. You can use this one as enrichment broth. Use of more strongly selective media as sodium gelatin sulfate broth for all this Vibrio cholerae. Okay. Or in for Vibrio parahemolyticum, you can use glucose salt depot broth. So as I've said, PCBS media, this is a selective plating media for this organism. Okay. Vibrio polyso. So colony characteristics, there is no sucrose fermentation. You will get the dull green colonies in contrast to sucrose fermenting species such as Vibrio celery, which produces yellow colonies when incubated at 37 degrees Celsius for 24 hours. Then you can count for the total viable count and other specific pathogens which are similar to that of the meat. So this is how we have to do. Okay. So main important thing is that what is the enrichment media? That is this alkaline peptone water with pH 8.6 supplemented with 3% sodium chloride, or this sodium gelatin sulfate broth can be used. Then the selective plating is thioglycolate citrate by salt, that is the TCBS. Okay, so with that we can isolate the organisms. So remember that the pH of the fish is 6.2 to 6.5. Because of that, it has a shorter storage life in compared to other meat. Okay, so that is all about today's class. So do you have any question to ask? Anyone? Do you have any question? Hello, are you there?
Yes, ma'am.
Yes.
Ma'am.
Any question you have? Those who came late, two students came late, I think, no? After I took after I took your attendance. So you can tell me your roll number. Do you have any questions from the lecture classes? We okay. I have clumped all together in this in one class. This inspection of fish as well as inspection of the egg, and so many terms are there. No, like mottling, then yolk centering, stock yolk, rotting, then those specific gravity of egg, pH of yolk, albumin. then whole egg, then pH of fish. Okay, so all those small things, try to remember. It will come in your objective. Okay, lots used to come from this class. Okay, anything? Anyone? Who came late? You can tell me your roll number.
Ma'am, 2023.
Ma'am,
19V23. Okay, and one more?
ma'am, 2019 V26.
26. Okay. There is no if there is no question, then shall we stop the class? Hello?
Yes, ma'am.
Okay. Uh okay, one announcement. I will try to give the notes to your CR again, assistant CR. I will give her, and I hope that she will directly give it to the class group. Read it, okay? Public health, it is very easy to understand, but for exam point of view, it is very confusing sometimes. If you don't read if you don't read slowly, na, if you read at a time in once, na, in one night or like that, you will get confused. Okay, that's why in order to avoid that one, I have given you as fast as I can the notes. Okay, so as soon as you get it, you try to read it, mark the important points, and keep it so that when you read again, it will be a little bit easy to remember. Otherwise, if you pile up and read in one night or like that, you will get confused. Okay, very easy to understand, but a little bit difficult to remember all the points and all. No, okay. See you in the next class then.
Thank you, ma'am.
Thank you,
Welcome,
ma'am.
welcome.